So our next topic is address translation in non-contiguous memory allocation. As we already discussed the address translation in contiguous memory allocation, where what was that? If we know the base address of the process, then we can add the offset with it and we can get the actual instruction address, right? But here in non-contiguous memory allocation, as you have seen that the processes pages are stored in different places. So how do we find that? Using the page table. So this address translation has to be understood before discussing any other thing related with paging. But before understanding the address translation in non-contiguous memory allocation, you first understand how. First, you tell me, if you have one bit binary, one bit, how many combination you can generate with it? 1, 0 or 1, right? So 2 combination can be generated. If you have 2 bits, then how many combination? 4 combinations, 0, 0, 0, 1, 1, 0, 1, 1. This 4 combination with 2 bits. And if you have 3 bits, you can have 8 combinations, right? So what is actually it is? If you have been given the number of bits of an address, so would you be able to find out the size of the memory? Yes. How? If we have n bits means n bits. And as you know, the 1 bit will generate the 2 combination. Second bit individually generate 2 combination. In the same way, 2 to the power n combination can be generated with the n bits. So if you know the address which is generating, it is of n bits, so you can definitely find out the size. But before actually calculating the size of the memory, first we have to find out the number of locations that can be made using n bits. So how many number of location can be made with n bits? 2 to the power n location. Understood? So if you have been given the number of bits, you can calculate the number of locations in the memory, right? Just assume this is memory and it is of the address of each instruction is of n bits, right? N bits. So if each location is n bits, so you can calculate this number of location with what was that? 2 to the power n locations. So how would you find out the size of this memory? Number of location into size of each location will give you the memory size. This may be the formula, right? Memory size will be equal to the number of locations into size of each location. But here we have find out the number of location, but what is the size of each location? It is actually depends on the operating system. The size of each location is default, we take it as a byte addressable memory, that is 8-bit, or word addressable or bit addressable. But byte addressable is the default one. If you have been given the memory is word addressable, then you have to take it as a word addressable. But here we are taking most by default. If nothing has been given, you have to take the size of the each location is 1 byte, right? The size of each location, we are talking about this, the size of each location, that is 1 byte, right? So one more thing you have to understand, what is the value of 2 to the power 10? It is 1024. We also call it as 1K, right? 2 to the power 20, it is 1 mega. 2 to the power 30, it is 1 giga. Then 2 to the power 40, 1 tera. 2 to the power 50, it is one better, right? You first understand or remind, you should know all those things before going for the paging numericals, right? So if I say what is the size of memory if the number of bits of each address is 14 bits and the memory is byte addressable, how would you find out? The same thing. 14 bits means the address of each location is of 14 bits. So do you able to calculate the number of location? Yes. How? So we have to calculate the memory size, which is equal to the number of location. What would be the number of location with 14 bits? 2 to the power 14 bits into the size of each location. And what it is given? The system is byte addressable. That means 1 byte. So if I break it like this, is it okay? Yes. And as you know, to the power 10 is 1024, that is 1k. So if I can write 2 to the power 4 1 kb, and what is 2 to the power 4? 16. So 16 kb. If the address bit is of 14 bits, the memory size will be 16 kb. So could you find out for 24 bits 2 byte and 32 bits with 1 byte memory addressable? This is the task for you, right? Let me do this thing. So how memory size, how many number of locations you can make with 24 bits? To the power 24 and 2 byte, right? 2 power 24 can be divided into like this, 2 power 24 and 22 byte. This 2 can be added here, 2 to the power 5, and 2 power 20 will be 1m, matlab mega, and then byte. So 2 to the power 25 is what? 32 megabyte. This is the size of the memory. So you calculate this 32 bits with 1 byte addressable memory, and give me the answer in doubt clearing session. Okay? You are able to calculate the size of the memory by having the number of bits of each address. But can you do the reverse process also? If you have been given the memory size, would you be able to calculate the number of locations? And if you get the number of location, you can get the number of bits to represent a single address, right? So for an example, if I take 64 KB is the size of the memory, would you be able to find out the number of location if the system is byte addressable? Let's assume this is n, and size of each location, the system is byte addressable. Would you be able to do that? Yes. How? 64 KB divided by 1 byte. Byte will be cancelled. So how many number of location can be there? 64k location. That is 64,000 locations can be there. Now if someone will ask you the number of bits to represent that memory, if the size is 64 KB, would you be able to find out that? Yes, definitely. How? We just take log. What is log? Log base 2 n to find out the number of bits. How? The upper limit. Log base 2. What is n? That is 64k. So first represent it with to the power 2 so that we can find out the number of bits. To the power 6 it is, and to k means to power 10. So one more line, to power 16. So the 16 bits will be there to represent a single memory address, right? So in the same way, if I ask you to find out 128 MB, if the size of the memory is 128 MB and the system is byte addressable, would you be able to find out the number of locations and the number of bits to represent a single address? Are you? So yes, we can. The memory size is 128 MB. Number of location is not known here, that we have to find out, and the system is byte addressable. So 128 MB divided by 1 byte, byte will be cancelled. What it is? To the power 8, I think. 7 to the power 7 M. So 128 M will be the number of locations. 128 mega will be the number of locations. So if we have, this one has been that we have got the number of location, and what about the number of bits? The same log you can take, and for shortcut you can do that. To the power 7 it is, and this is to power 20. 20 and 7, 27 bits can be the size of each address. So the next will be the assignment for you, that is 8 GB. The size of the memory is 8 GB. This is second one and the third one, and the system is 4 byte addressable. So you have to find out the number of locations and number of bits to represent a single address. So I will ask the answer in doubt clearing session. So once you know that how to convert memory size, how to get the number of bits and number of location from the memory size, or the if the number of bits are given, how to calculate the memory size. If you know all those things, you are ready for solving the paging numericals, right? So we'll be doing in the next session.